Dear students, now we are in the chapter of circles. In the chapter circles, until yesterday, we have discussed the relative positions of circles. In the chapter, the subtopic relative positions of circles, we have discussed the theorem and the positions and the condition of the circles if the two circles lie outside of the other. Now let us going to discuss another positions. Now we are in the topic relative positions of circles. Relative positions of circles. Yesterday we said that first position, that case 1, now case 2. Case 1 we discussed as two circles lie outside of the other. Two circles lie outside of each other, we have discussed yesterday. Now we are going to discuss about the two circles touch each other. So I am going to tell with you that the position of circles is compact. So it is moving aside. In yesterday discussion, two circles lie outside. So this circle is touching. Next this circle intersect. Next this circle inside, like that. So the distance of two circles is reducing. Now two circles touch each other externally. This is the condition. Two circles touch each other externally. Draw like this. This is the condition. This is C1. This is C2. C1, C2. Some staff used to say C1, C2 equal to D. What is D? Small d is the distance between two centers of the circles. C1, C2. Draw like this a tangent. And draw like this. This is P, this is Q. From center to any point of the circle is called as radius, this is R1. From center to any point of the circle is called as radius, this is R2. So now you can say that condition. In this case, we can write condition. C1, C2 is equal to R1 plus R2. Directly, it is visible, directly you can say. In this case, condition is C1, C2 is equal to R1 plus R2. In yesterday condition here, C1, C2 greater than R1 plus R2. In yesterday class. Now two circles touch each other externally. So condition is C1, C2 is equal to R1 plus R2. Next here you can write three tangents can be drawn to the given two circles. Three tangents. Three tangents can be drawn. Three tangents can be drawn to the given two circles. In yesterday class, four tangents can be drawn to the given two circles. Now here three tangents, letter 2, letter 1, letter 0, like that. The process will be coming. Given two circles, three tangents can be drawn to the given two circles. One general tangent. If we draw like this, this is a transverse common tangent, TR. If we draw like this, these are called as direct common tangents. Yesterday I said that. These are direct common tangents. In this case, this is a direct common tangent. Direct common tangent. So one general tangent I am writing here. One general tangent. And two direct common tangents. One general tangent and two direct common tangents. So therefore, point of contact, whenever only one line is there, then wherever the line touches the circle or circles, it is called as point of contact. So here P is the point of contact of circle 1 and circle 2 also. It is not a point of intersection of tangents or not point of intersection of transverse common tangent. If the point of intersection of transverse common tangent should exist, the circles should lie outside of the other. If the circles lie outside of the other, then point of intersection of transverse common tangents is called as ICS, internal center of similitude. If the direct tangents can be drawn, then point of contact of the point of intersection, not contact base, point of intersection of direct common tangent is called as external center of similitude, ECS. Here there will be no ICS, it is called as simply point of contact. So whenever circles touch each other externally, point of contact P is equal to, point of contact means for a general tangent. Point of contact P is equal to, in bracket I am writing, for a general tangent, only one tangent. For general tangent, P is equal to ICS because simply the point of contact is inside of the circles. Here there is no point of intersection, but single point of contact is there. That point of contact you can pronounce as ICS. ICS formula R1x2 minus R2 plus R2x1. ICS means internal center of similitude. Yesterday I said that. Internal center of similitude. Internal center of similitude. R1x2 plus R2x1 by R1 plus R2 comma R1y2 plus R2y1 by R1 plus R2. This is the point of contact. Of course, point of ICS, simply point of intersection should not pronounce, point of contact. Now ECS directly, ECS Q you write. ECS means external center of similitude of the direct common tangents. External center of similitude. External center of similitude Q is equal to, where yesterday I said the theorem, in the theorem model we should discuss. Q is dividing the line joining center C1 C2 in the ratio R1 is to R2 externally because the point is external. P divides the line segment joining center C1 C2 in the ratio R1 is to R2 internally because it is inside of the two circles. Now Q you can write R1x2 minus R2x1 by R1 minus R2 comma R1y2 minus R2y1. R1y2 minus R2y1 by R1 minus R2. This is the external center of similitude. Now case 2 completed. Let us discuss about case 3. Students, you observe whenever two circles touch each other externally, then point of contact is equal to point of contact of the two circles for general tangent. If he asks that find the point of contact of two circles, if three tangents can be drawn, then you should calculate ICS. Students used to get confused. Sir, whenever circles are external, then you should calculate the point of contact as ECS because EE. Don't get confused that whenever circles are touches externally, then you should calculate point of contact internal because the point is inside of the circles. It is general tangent. If he mentioned find the direct common tangent, then you should calculate ECS. If he did not mention point of direct common tangent, then you should calculate only ICS. For external, ICS you calculate. For internal, we are going to discuss in next topic. This is, if two circles touch each other internally, then point of contact is ECS because the point of contact is outside of the circles. Don't get confused that if the two circles touches internally, to find point of contact ECS you should calculate. Two circles touch each other externally, you should calculate the point of intersection ICS. Now case 3, two circles intersects. So the distance between two circles is becoming radius. Case 3. Two circles intersect each other. Two circles intersect each other. Let us draw a diagram. Draw like this. This is make as a tangent. Simply P. Because the two circles are intersecting, there will be no transverse common tangent choice, or there will be no direct common tangent transfer. General tangent choice. So the two circles, whenever intersecting, the distance between two circles is reduced more than case 2. Now what is happening? Only two direct common tangents. Now let us discuss about the case. Put here, this is the center C1. This is circle. Put here, P already we put. So Q. CP is R. R1. You can put here C2 center. Now this is the point R. So UCQ is R1 and CR is R2. In this case, you can write. In this case, condition is modulus of R1 minus R2 less than C1 C2 less than R1 plus R2. Somebody used to say C1 C2 less than R1 plus R2, but this one also you should remember. In IP and objective also this is important. Modulus of R1 minus R2. That means the difference between the radii and sum of radii lie between C1 C2 line joining centers. The distance line joining centers lie between this one difference between radii and sum of radii. So here try to understand that R1 plus R2 is less than C1 C2. C1 C2 less than R1 plus R2. The distance is more. It is clearly visible. Now in this case only two direct common tangents can be drawn. In this case only two direct common tangents. These are not a transverse common tangent. These are direct common tangents. Only two direct common tangents can be drawn. The point of intersection of direct common tangents. The point of intersection. Direct common tangent ECS is equal to, here P is equal to R1 x2 minus R2 x1. R1 x2 minus R2 x1 by R1 minus R2, comma R1 y2 minus R2 y1 by R1 minus R2. That's all. Now let us go into discuss case 4. Case 4. Here two circles intersect each other. Next, two circles touch each other internally. Two circles touch each other internally. The condition is two circles touch each other internally. Draw a diagram like this. This is the case. Put here C1. Put here C2. This is C1 C2. From C1 to write like this. This is R1. This is R2. Now observe what is happening. In this case, C1 C2, the distance of C1 C2 is equal to total distance R1 minus R2. In this case, the condition is In this case, condition is C1 C2 is equal to modulus of R1 minus R2. Why? Because modulus of R minus R2, why you had written sir, you can ask R2 minus R1 also you can write. But the distance C1 C2 line joining between centers should be positive. That is why you should write modulus of R minus R2 or R2 minus R1. Anything, no problem. But if you get minus 5, you should put 5. That's all. If you get minus 6, you should put 6. Because line joining centers is a distance always positive. Here draw a tangent, only one tangent. Put here P. In this case, only one general tangent only one general tangent can be drawn. Point of intersection or point of contact, there is no intersection. Point of contact is equal to here. Since you observe here, the two circuits touch each other internally, then point of contact is outside of the circuits. That is equal to ECS. So ECS P is equal to here R1 X2. R1 X2 minus R2 X1 by R1 minus R2 comma R1 Y2 minus R2 Y1 by R1 minus R2. That's all. So now you observe, once again I am telling you that if two circuits touch each other externally, we got just a rub down. If two circuits touch each other externally, to find the point of contact, we should calculate ICS, because the point of contact will be middle of the circuits. If two circuits touch each other internally, then you should calculate the point of contact is outside, ECS, because the point of contact lie outside of the two circuits. ECS formula R1 X2 minus R2 X1 by R1 minus R2, R1 Y2 minus R2 by R1 minus R2. While ICS formula R1 X2 plus R2 X1 by R1 plus R2 and R1 Y2 plus R2 Y1 by R1 plus R2. Now case 4 is there. So case 4 completed, case 5 is there. Case 5. Two circuits lie inside of the other. Two circuits lie inside of the other. Draw like this. You can put C1 here and C2 here. Join. C1, this is R1. C2, this is R2. Simply put like this. So the distance in this case I am writing. In this case, here we got C1 C2 is equal to R1 minus R2. In this case you can write C1 C2 less than modulus of R1 minus R2. So the distance between C1 and C2, line joining C1 C2 is less than the difference of the radii. Whenever less than the difference of the radii, if two circuits lie inside of the other, then there is no chance to draw a tangent. Therefore, number of condition is this one. This is condition. Number of tangents. I am writing here, no tangent can be drawn. No tangent can be drawn in this case. So, once you observe that case 1, case 2, case 3, case 4, case 5, 5 cases are there. For first case, plenty of theory we have discussed. C1 condition is C1, C2 greater than R1 plus R2. Number of tangents equal to 4. Direct common tangent is there, 2 direct are there and 2 transverse are there. Total 4 tangents can be drawn. ICS formula we have discussed, ECS formula we have discussed. Second case, C1, C2 is equal to R1 plus R2. Two circuits touch each other externally. 3 tangents can be drawn. So tangents is reducing and circle's position, distance between two circles is reducing. Total 5 in the total 5 cases. In second case, C1 C2 is equal to R1 plus R2. In third case, C1 C2 modulus of R1 minus R2 less than C1 C2 less than R1 plus R2. Only 2 tangents can be drawn. That too only 2 direct common tangents. There is no transverse common tangent or there is no general tangent. Next, in fourth case, 2 circles touch each other internally. Only 1 common tangent can be drawn. That too, the point of contact is ECS. Of course, it is only general tangent in next place. In the fourth condition, C1 C2 is equal to modulus of R1 minus R2. In the fifth condition, C1 C2 less than modulus of R1 minus R2. There will be, we cannot draw any tangent. No tangent can be drawn. So number of tangents equal to 0. Observe that total 5 cases, number of tangents 4 in first case, number of tangents 3 in second case, number of tangents 2 in third case, number of tangents 1 in fourth case, number of tangents 0 in fifth case. Remember this one as a table also, as a formula also. For objective, not for mains. In mains 2013 he asked. In 2013 he asked how many number of common tangents can be done. It is easy bit. In MSET, regular chances there. In MSET depends upon such questions. It depends upon these conditions. Okay, let us discuss about a theorem depends upon the pair of tangents. A 7 mark IMP theorem is there regarding in this exercise 1E concept. Seven mark IMP theorem. In the chapter of circuits, only this theorem is important. The combined equation of pair of tangents statement will be given in exam, students. You should not write, no need to write statement. We will give the combined equation. The combined equation of pair of tangents drawn from an external point. The combined equation of pair of tangents drawn from an external point P x1 comma y1 to the circle S equal to 0 is S1 square equal to S into S11. This is the statement of theorem. Already we have learned that 2 tangents can be drawn from an external point to 2 circuits, and angle between tangents we have drawn depends upon locus sums and tangent of equal to R by root S1 perpendicular conditions of polar everything concept we have discussed. Now we are going to discuss about the pair of tangents combined equation. Proof. Draw a diagram like this. This is the point Px1 comma y. From the point Px1 comma y1. From the point Px1 comma y1, here we have drawn 2 tangents. Draw a secant like this. Put A here and put B here. General notation of circle, any point on the circle is x comma y, because equation of circle x minus h whole square plus y minus k whole square equal to r square in general form, where h comma k is center and Cp is equal to r. By depends upon Cp is equal to r, we have calculated P x comma y and point on the circle h comma center. Distance between Cp is equal to r, we have length, and Cp square is equal to r square we have taken. By the taking of Cp square is equal to r square, x minus h whole square plus y minus k whole square equal to r square we have written. So that is why I am writing here b x comma y be any point. B x comma y be any point. So many methods are there to prove this theorem, students. What is the easy method I am saying to you? Let now the point A, let PAB be a secant, but point A divides the PB, the secant in the ratio k is to 1. This is k and this is 1. The point A in the ratio k is to 1. Now, let the circle I am writing here, let the circle be. let the circle be. Notations I am writing. S is equal to x square plus y square minus r square. Students, we can take x square plus y square plus 2x plus 2f plus c equal to 0 also, but it becomes lengthy. It is a circle, s is equal to 0, and x square plus y square equal to r square is also a circle, s is equal to 0. We can notate with the letter s this one also. It becomes easy model. S is equal to x square plus y square minus r square. Now, I am saying the notations depends upon this one. S1 notation xx1 plus yy1 minus r square. Next, S11 notation here. S11 notation x1 square plus y1 square minus r square. Next, S12 notation x1 x2. x1 x2 plus y1 y2 minus r square. Now, AB over this, put here, this is Q and this is R. Let Px1 comma y1 be an external point. Px1 comma y1 be an external point of a circle x equal to 0. Be an external point of a circle s is equal to 0. Now, let B capital B. X comma y be any point. Px1 comma y be external point of the circle s equal to 0. Two tangents PQ comma, next line I am writing as, let PQ comma PR be the two tangents. PQ comma PR be the two tangents drawn from Px1 comma y1 to the circle. Drawn from Px1 comma y1 to the circle s equal to 0. To the circle s equal to 0. Next we can write, let PAB, put like this, let PAB be the secant line of circle. Secant, enough. Secant of circle. Secant of circle. Whenever the line secant of circle, then we can understand that B, the line P, the line PAB is a secant, so the line, whatever line drawn from outside of the circle intersect the circle into distant points. So let, here I am writing Bx comma y. Let Bx comma y be any point on the circle. Let Bx comma y be any point on the circle. Now let A, capital A, divides PB. Let capital A divides PB in the ratio. Capital A divides PB in the ratio k is to 1. That implies A is equal to, whenever it is dividing in the ratio k is to 1, formula mx2 plus nx1 by m plus 1 model kx plus x1 by k plus 1, comma ky plus y1 by k plus 1. Put a comma, since this A, since A lie on a circle, since A lie on a circle s equal to 0. So this A lie on the circle s equal to 0. So A you can substitute here in s equal to 0, x square plus y square minus r square. Put s11 equal to 0 model. That implies you can put here kx plus x1 by k plus 1. Kx plus x1 by k plus 1 whole square. Plus here you can put ky plus y1. Ky plus y1 by k plus 1 whole square minus r square equal to 0. Now depends upon a plus b whole square formula. You can write here as k square x square plus 2k xx1 plus x1 square plus k square y square plus 2k y1 plus y1 square minus r square into this one taken LCM, it becomes r square into k square minus 2r square k minus r square equal to 0. K plus 1 whole square taken common and multiplied with r square. That implies, now you take common k square, then you can write here, whenever you have taken common k square, then you can write here as x square plus y square minus r square. Try to understand that this k square x square, k square y square and r square k square taken common. Next you can take common as 2k, it becomes within the brackets xx1 plus y1 minus r square, xx1 plus y1 minus r square. Later you can write without common, x1 square plus y1 square minus r square equal to 0. For this one only I had written every notation here. Xx1 plus y1 minus r square is equal to s1 and x1 square plus y1 square minus r square equal to s11 and s is equal to x square plus y square minus r square. That implies you can write here k square s square, k square s square plus 2k into s1 plus this is s11 equal to 0. Put it a name 1. Now I am writing if secant PAB, this is a quadratic equation. This is a quadratic equation in K I am writing. This is a QE in K. QE means quadratic equation. This is a quadratic equation in K. If secant PAB becomes tangent, secant PAB becomes a tangent, then roots of 1 are equal, should be equal. Roots of 1 are equal. Because so many times I discussed the concept that quadratic equation having two roots. If the two roots are distinct and real, a line intersects the circle in two distinct points. If the roots are equal, the secant becomes tangent, because there will be no two roots, there will be a single root. Even though they are having two roots, the roots are equal. Then only secant becomes tangent. P approaches to Q and Q approaches to P. I said that the definition of tangent is the limiting point of secant is nothing but tangent. So here this PAB, if A becomes B, it is reducing like this. Then what will happen? Only one point you may get, the point is point of contact. Now I am going to discuss about pair of tangents. That is why for the equation, pair equation, what is pair here? Quadratic equation. If the roots are quadratic equation, if the roots of quadratic equation are equal, then secant becomes tangent. Whenever secant becomes tangent, we get the equation of pair of tangents. Now you write here 1 are equal. Now what is the value of discriminant? Roots are equal, the condition is whenever two roots are equal, that implies delta is equal to b square minus 4ac equal to 0. A is equal to, you can write s, b is equal to, you can write 2s1, a is equal to s, b is equal to 2s1 and c is equal to s11. Notation: a is equal to s, b is equal to 2s1, because this is a quadratic equation in K, and c is equal to s11. Now using the definition of b square minus 4ac equal to 0, you can write now 2s1 whole square. 2s1 whole square minus 4 into s into s11 equal to 0. Now you write divide by 4 both sides. Divide by 4 both sides. Hence, equation of pair of tangents of circle equation of pair of tangents or combined equation. Pair of tangents of circle. Combined equation of pair of tangents of circle s equal to 0 is s1 square is equal to s into s11. This is the IMP theorem. Because by dividing 4 you can get 4s1 square. Here I am writing a step as 4s1 square minus 4s into s11 equal to 0. Whenever you divide it, it becomes s1 square minus s1, s dot s1 equal to 0, s1 square is equal to s into s11. This is the theorem, most IMP theorem, students. Maybe if he is not asking sum in the exercise 1E concept, he will ask the theorem only. Only this theorem is important in circle chapter. Now, concept is completed, we can do sums now. Common tangents concept, what is important in exercise 1E, we have completed. Now, let us discuss some examples. According to schedule I want to write to you. Whatever the sums I left, you should do the work. Example 3, page number 66. Page 66, example 3. And example 4 also, example 3 and 4. Later page number 68, example 1. Example 1, page number 68. Let us finish this one. Show that the circles. Show that the circles x square plus y square minus 4x minus 6y minus 12 equal to 0, comma x square plus y square plus 6x, x square plus y square plus 6x plus 18y plus 26 equal to 0. Touch each other. Touch each other. Touch each other. Also find point of contact and common tangent at point of contact. Also find point of contact. Also find point of contact. And find equation of common tangent, and find equation of common tangent at this point of contact. Equation of common tangent at this point of contact. So that the circles x square plus y square minus 4x minus 6y minus 12 and x square plus y square plus 6x plus 18y plus 26 equal to 0. Okay. Given circles I am writing. This question also given in IPE for 7 marks. Given circles S is equal to x square plus y square minus 4x minus 6y minus 12 equal to 0. Next step, S dash I am taking. X square plus y square plus 6x plus 18y plus 26 equal to 0. Here you can write as C1. This model questions depends upon exercise 1E concept. For every circle, this is the process. C1 you should calculate, C2 you should calculate, R1 you should calculate, R2 you should calculate. C1, C2 distance also you should calculate. Depends upon the condition we can decide how many tangents can be drawn. C1 is equal to here 2 comma 3. R1 is equal to root of g square plus f square minus c. So 4 plus 9 plus 12 over root, it is 5. So C2 is equal to here minus 3 comma minus 9. Minus 3 comma minus 9. R2 is equal to, this is 9 plus 81 minus 26. 9 81 is 90. 90 minus 26 is 64. 64 root 80. Now you can write C1, C2. That is the distance between the centers. According to the root of x2 minus x1 whole square plus y2 minus y1 whole square concept, 2 plus 3 whole square, it is 25. 2 plus 3 whole square is 25. 3 plus 9 whole square, 12 square, it is 144. So C1, C2, 25 plus 144 over root, that is 13. C1, C2, 13 we got. So now let us discuss here R1 plus R2. So R1 plus R2 means 5 plus 8 is equal to 13. Therefore 13 equal to 13. What we got here using the value 13 equal to 13. So C1, C2 is equal to R1 plus R2 we got. C1, C2 is equal to R1 plus R2. Whenever C1, C2 is equal to R1 plus R2, we should use that case 2. Case 2 condition. This is the C1, C2 equal to R1 plus R2. He is asking that find the equation of common tangent at this point of contact. Means point of contact you should calculate as ICS. This is the P, enough. This is the P, point of contact. Now you write two circles. The position I am writing, two circles touch each other externally. Whenever C1, C2 is equal to R1 plus R2, two circles touch each other externally, you should write. Touch each other externally. Put like this, it is a C1 and it is a C2. Draw like this. This is R1 and this is R2. C1, C2 is equal to R1 plus R2. Point of contact. Point of contact is equal to ICS. ICS formula, once again I am making you to remember that R1x2 plus R2x1. R1x2 plus R2x1 by R1 plus R2, comma R1y2. R1y2 plus R2y1 by R1 plus R2. So what is R1, what is R2? R1 is, everything is clear here. R1x2. So here I am writing ICS is equal to, put a name here P. ICS is equal to. Students, this is x1 comma y1. So C1 2 comma 3 is x1 comma y1 and this is C2 minus 3 comma minus 9 is x2 comma y2. R1 x2 you write here. So R1 x2 means 5 into minus 3 plus R2 x1. So it is 8 into 2 by R1 plus R2. You put 5 plus 8 comma R1 y2. So R1 is 5. Y2 is minus 9 plus R2. R2 means 8 into Y1 means 3 by, this is 5 plus 8. You can write here now P is equal to R1, this is minus R1x2 plus R2x1 minus 15 plus 16. So it can be written as 1 by 13. 1 by 13 comma, this is minus 45 plus 24. It is minus 21 by 13. 1 by 13 comma minus 21 by 13. Now using this one at the point of contact we got. At the point of contact we should calculate equation of tangent. Equation of tangent using P comma circle 1 S equal to 0 you write. Using P comma S equal to 0 formula S1 equal to 0. S1 equal to 0. S1 equal to 0 notation xx1 plus yy1 plus g of x plus x1 plus f of y plus y1 plus c equal to 0. X into, now you write 1 by 13. Using circle S equal to 0 you observe this one. Y into minus 21 by 13 plus g means here minus 2. Minus 2 into x plus 1 by 13. Minus g into x plus 1 by 13 minus 3 into y plus 21 by 13. Minus 12 equal to 0. That implies we can take LCM as here x minus 21y minus 2 into 13x plus 1 minus 2 into 13x plus 1 minus 3 into 13y plus 21 minus 3 into 13y plus 21 minus 3 into 13y plus 21 minus 13 12s are 156. That implies x minus 21y minus 26x minus 2 minus 39y minus 63 minus 156 equal to 0. X minus 26x you can write as minus 25x. Next this is a 60y. This is a 2, 3, 63, 63 and 150. 65. 65 and 156. This is 12, 13, 13, everything okay. Minus 2x, minus 2y, 13. So, minus 2, minus 3, minus 63, exactly right. Now we can write 156, 20, 2, 63, 65, 65, 156. 221. 13 into 12. Let us verify. Of course, 12. These are 36, 3, 12. 1 are 12, 3, 156. It is absolutely right. Somewhere it is going. X into 1 by 13 plus y into 1 by 13. This is minus y minus 21 by 3. This is mistake, students. Here minus I put. So this becomes plus 63. So now 63 minus 158. Let us discuss 158 minus 63. This is 5, this is 9. Okay. So 95 it is. Minus 60 and this is minus 95. Equal to 0. Divide by minus 5. You get the required equation. Divide by minus 5. Required equation of tangent. Required equation of tangent is 5x plus 12y plus 19 equal to 0. Put a star mark for this question. This is important in MCET also. Sometimes he asks in MCET direct bit. Plenty of times I am discussing with you that IPE 7 marks bits will be asked in MCET. 10 questions will be there. Whether belong to first year or second year, some questions are there. You should remember the questions or you should by heart the questions. Whatever you need you do. But you should remember this answer also. 5x plus 12 plus 19 equal to 0. Directly given the question. In our objective material, in level 1 maybe 71st question like that is there. In level 1 homework is also such model question is there. In some materials, in some guides, they will give the hint like this. Whatever the guide prepared, the staff member will not do this one. Whatever the next concept is there, system of circle. S minus S dash. Whenever this one minus this one, you get the answer as equation of tangent. Example, let us do this one minus this one. So S dash minus S. S minus S dash or S dash minus S is called as common tangent concept. You can learn in radical center, radical axis concept in system of circle next chapter. Some staff member used to say and some guide also used to give like this only. 6x plus 4x it is 10x. 18y plus 6y it is 24y. 10x plus 24y plus 38. 10x plus 24y plus 38 equal to 0. Divide with 2. 5x plus 12y plus 19 equal to 0. Simple model. Whenever he given for 7 marks, you do in this model. This is the correct way of the circle chapter. That is the way of system of circle chapter. But whatever I said, you follow this method for this question. Example 3 completed. Now let us going to discuss example 4. It is there, show that the circles in the same model and touch each other and find the point of contact he is asking. Okay, let us discuss in next class, students.